Hi, welcome to the class. Today we are going to continue Unit 1, that is electrostatic. So yesterday we studied about Coulomb's law. So let us just go through the expression for the Coulomb's law. So Coulomb's law basically gives us an expression to calculate the force between two charged particles, and the force between two charged particles is given by 1 upon 4 pi epsilon naught q1 q2 upon r square. Also we had studied that Fm, which is the force between two charged particles kept in some medium, upon F, which is the force between two charged particles when the two charged particles kept in air or vacuum, which we call free space, is equals to epsilon naught upon epsilon. Now yesterday this I forgot to mention that epsilon naught upon epsilon is known as this ratio. Epsilon naught upon epsilon ratio is known as 1 upon epsilon r. And what is this epsilon r? Epsilon r is relative. Epsilon r is relative permittivity of that particular medium with which we are with which we have taken the ratio of this permittivity of free space. So this is permittivity of free space. This is permittivity of some medium, can be water. So then in that case, if it is water, in that case it will be relative permittivity of water. And further this was equal to 1 by k, and we understood that if we keep two charges in some medium, then Fm upon F is equals to 1 by k. That means the force will decrease because of the change in medium. So let us do this question. Now before starting this question, let me tell you, in the very first video which we have uploaded, in the description section, I have put up a worksheet which I called a mind map, in which you can find for unit 1, whole unit 1. I'm talking about whole unit 1. You will find the question, and the questions will be put up topic wise. So you'll get topic wise questions there, and also the notes are being put up of this particular chapter within this unit. So as you move on in the very first video itself, you will get the notes, and also you get the question. So this is the question which is taken from that mind map, and it reads out relative permittivity of water is 81. So relative permittivity of water is given 81, and if EW, because water is some other medium, if EW at epsilon naught are permittivities of water and vacuum respectively, find the relation between them. So we will use this relation, epsilon naught upon epsilon W is equals to 1 upon epsilon R. If I reciprocate it, it will be epsilon R is equals to epsilon W upon epsilon naught. This will be 81 is equals to epsilon W upon epsilon naught. So as you can see, epsilon W, that is the permittivity of water, is equals to 81 epsilon naught. So this will be the relation which they wanted us to calculate, right? One more question we will do, and as I told you that we will be doing questions from the mind map, which is being put up in the description section of the first video, that was the introduction to electrostatic. So from that you will see subtopic is written if you download it. So subtopic is charge, Coulomb's law, it is written like this. And then the question which I am taking is from type 1, and this is the fifth question. So this question reads out 2-point charges having equal charges. So we have 2-point charges and they are having equal charges. So let us assume both have equal charges, that is Q. They are separated by distance 1 meter. It is also given in the question. Experiences a force of 8 Newton. They are experiencing a force of 8 Newton. What will be the force experienced by them if they are held in water? So the same charges kept same distance apart. Now they are kept in water. So what will be the force experienced? This we have to figure out. And the value of dielectric constant K, this K, which is the dielectric constant. The value of dielectric constant for water is given as 80. Now we can use this formula directly, F upon F. So So in case this is the case with water, medium is water now. Fw upon F is equals to 1 upon K. So I have to calculate the force in water. Fw is equals to F is 80 upon K is 8. So force is 10 Newton. So as you can see, when the same two charges kept at the same distance apart, they were kept inside the water, the force has reduced by 1/8. So earlier the force was, okay, so I have done a mistake here. So this F is 8 and this is 80. So it will be 1/10, that is 0.1 Newton. So you can see the force has reduced. So the force has reduced not because the product of the charges has reduced or the distance has reduced or there is any change in these two factors. It has reduced because the medium has changed. So this was the question which I wanted you people to understand based on this whole thing. Now, yesterday we studied about Coulomb's law, and Coulomb's law tells us the force between two charged particles, and as you know that the force is a vector quantity. So in Coulomb's law, if I write the law, F is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So in Coulomb's law you can see this is the force given, but force is a vector quantity. So it is a vector quantity. From this expression I cannot make out the direction of this force. I need the direction of this force also. So that is why I am starting something which I call Coulomb's law in vector form. So I study this Coulomb's law in vector form in order to understand the direction of the force. Okay. So this is again very simple thing. You can take it Q1. This is Q2. They are separated by some distance. Now here if I write the distance, it is going to be R vector. R vector is a distance. Okay. So let me write the force experienced by this Q1 by Q2 is F12, and the force experienced by Q2 because of this Q1 will be F21. So let me write the meaning of these things first. F12, force on Q1 due to Q2, and then F21, force on Q2 due to Q1. Then vector R12. So vector R12 I am taking as position vector of Q1 with respect to Q2, and then R21 is equals to position vector, actually it is position vector of Q2 with respect to Q1. Now you all need to understand that this R vector has got two things with it. One is the magnitude of this vector, another is the direction of this vector. Remember this thing, and it is valid for these two things, the same thing. Now if I have to write F12, you all know the formula. Q1 Q2 upon R square. Guys, this is the magnitude. So I'll write magnitude, no arrow because it is not a vector, it is the magnitude. And then I'll write R12. This cap vector, you know that it represents the direction. So the direction of this force is along this line. From this to this. Okay, as we know that R12 is the position vector of Q1 with respect to Q2. So with respect to Q2, the position vector of this Q1 with respect to Q2 is this R1. So it tells us the direction. Now in place of this, using this, what I can write? R cap is equals to R vector upon magnitude of R. If I write it, F12 is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Now place of this, I'll write vector R12 upon magnitude of R. In place of this I have put it here. F12, actually I should write R12 itself, because this is the magnitude for R12, and then 1 upon 4 pi epsilon naught Q1 Q2 upon R12 cube, and then this vector. So this is the formula for Coulomb's law in vector form, and this will be true for the other force also. If I write the same expression, so I will write similarly F21 is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R21 cube, and then this will be R21. Now guys, remember one thing, that R12 is the position vector of 1 with respect to 2, and R21 is the position vector of Q2 with respect to Q1. This R12 and R21, they are equal in magnitude. This magnitude will be equal for both these two. Why? Because the distance is the same, but they are opposite to each other. One is telling you from with respect to this the position of this vector, other is telling you the position of this particle with respect to this particle. So they are in opposite direction. That is the only difference. So instead of this, if I write F21 is equals to 1 upon 4 pi epsilon naught Q1 Q2 upon, now you know that this magnitude and this magnitude are equal, only there is a change in direction. If I write it as R21 square, as it is I am writing, I can write it as R12 also, or I can keep it, I can change these two. Why? Because the magnitude is same, distance is not going to change. So if I write it as R12, again I am telling you why I have written it R12, because the magnitude of this and this is going to remain same, only there will be a difference of direction. In the first case it will be from this point to this point, and in the other case this point to this point, but this distance will remain same. So what I am going to do now, instead of this R21, I am going to put negative R12. Now if you look at this, F21 is equals to negative, I have written, minus Q1 Q2 upon R12 square, and then R12. If you look at this is equal to F12. So if this is equal to F12, that makes F21 is equals to minus F12. Now if you look at this expression, it reminds me of Newton's second law. It means these two charged particles, when they are exerting a force on each other, they obey Newton's third law also. For every action there is an equal and opposite reaction, right? So from Coulomb's law in vector form, I got to know two things. One, I got to know the direction of the force, which I was not able to get earlier when I was dealing with the Coulomb's law. And the second, I got to know that it obeys Coulomb's law is valid, or the Newton's third law is valid for Coulomb's law, right? So this was your Coulomb's law in vector form, and that is it for today. Thank you.